Good afternoon, classes. This is Mr. Holmes. Today we're going to be discussing property of exponents, part 2 now. So we're just going to go into a couple more formulas, examples with how to apply exponent properties. But first off, we're going to just review the first part of the properties of exponents, the three things we talked about: product rule, quotient rule, and negative exponents. So let's just put down the theorems again. So the first one was our product rule. And our product rule just states whenever I have two pieces in exponential form, I just, with the same base, I keep the base and I add the exponents. And I can do it with 3, 4, 5. As long as the bases match, you just add all the exponents together, keep the base. That's the only thing that changes, the exponent part. Quotient rule, very similar. The quotient rule just states to divide when two bases are the same. You write the base, subtract the exponents. So when it's in division form, like so, with the fraction, and the bases match, you keep the base and just subtract the exponents, m minus n. And then our negative exponent rule, remember, is when you have a fraction bar, you wherever the negative is, you move it to the opposite part of the fraction. So if it's negative in the numerator, it's positive in the denominator. Negative in the denominator, positive in the numerator. So you just move it to the opposite part of the fraction, and that becomes your new form with a positive exponent. So x to the negative m is really the same as 1 over x to the positive m. So notice the base isn't changing, just the sign of your exponent. You can also write it like this. If it was negative to start in the denominator, it's now positive in the top part of the fraction and numerator. So those were the three from last video. Now we're going to get into our zero exponent rule. So I'm going to make a quick table. So I'm going to do 3 to the 4th, 3 to the 3rd, 3 to the 2nd, 3 to the 1st, and 3 to the 0. So basically what I'm trying to figure out is, without using a calculator, what is an exponent raised to the 0 power? What does it equal? So 3 to the 4th is really just 3 times 3 times 3 times 3. That's 81. 3 to the 3rd is 27. 3 to the squared, 3 squared is 9. And 3 to the 1st is 3. So just looking at this, do you see a pattern going on? So to go from 81 to 27, I'm really just dividing by 3. 27 to 9, I'm dividing by 3 again. 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. So what do you think would go here? If I continue the pattern and divide by 3, I'm going to get 1, not 0. So some of you may have thought a number raised to the 0 power is 0, but it's really 1. And we can check this on the calculator. If I do 3, the y to the x button, and then hit 0, you get 1. So this leads us to our zero exponent property, which is the following. Give me 1 second. Okay, this is our zero exponent rule. Any base except 0. So I can't have a base of 0. I can't do 0 to the 0 power. You can't do it. It's indeterminate. And we'll discuss, you'll get to know more about that in higher level math. So any base except 0 raised to the 0 power is 1. Any base except 0 raised to the 0 power is 1, equal to 1. So it looks like this. X to the 0 equals 1. Or I can do like 5 to the 0 equals 1. Those are some examples. So that is a very important rule. So if you ever see something raised to 0 power, you can just automatically make it 1, unless the base is 0, and you're not going to really see that as a trick question. So that's the 0 exponent rule. Now we're going to look at our power rule. So underneath this now, let me see. Okay, let's say I had something like this. 7 to the third squared. And I wanted to figure out what this is. So remember, when I raise something to an exponent, I'm just taking the base and multiplying itself that many times. So really, this is just, think of it like this. 7 cubed is really 7 times 7 times 7, and then I'm squaring it. So really, I'm just multiplying this by itself. So really, this is just 7 times 7 times 7 multiplied by itself. And if you look at it, how many 7s are there? There's 6 7s being multiplied. So really, this is just 7 to the 6. Let's look again at this one. 8 to the 4th cubed. This is just 8 times 8 times 8 times 8 to the 3rd power. If I do this, it's just 8 times 8 times 8 times 8, and then I'm doing that by itself 3 times. And if you look, how many 8s are there? 4, 5, 6, 7, 8, 9, 10, 11, 12. So do you see a pattern? 7 to the 3rd power squared is 7 to the 6th, and 8 to the 4th power to the 3rd is 8 to the 12th. If you look at these, I'm just taking the exponents and multiplying them together. So when I have a number in parentheses raised to some other exponent, I just multiply the exponents. This is my power rule. Power rule. And the power rule just states, when I have a power to a power, that's when it's in parentheses, raised to something else. It must be in parentheses to use this rule. Power to a power. You write the base, and multiply the exponents. So, power to power, write the base and multiply the exponents. And it looks like this. So, something raised to another power, keep the base, and just multiply the exponents together. So x to the m to the nth power is really just x to the m times n power. Or if I can also use, it doesn't just have to be a single base. I could have 2 different bases doing it. So I could have something like this. So if I have 2 different bases being multiplied to a power in parentheses, this just becomes x to the m times y to the m. I take each piece separate and raise it to the power. And I can also do it for division. If I'm dividing 2 pieces, all raised to the same power, I just do each piece to the exponent on outside. So x to the m over y to the m. So wherever it is, it stays in that piece. So the x stays in the numerator, the y stays in the denominator, and they're both just raised to the power on the outside. So those are the 3 forms. So let's look at a couple examples how to apply them. So the first one, x cubed squared. So I can use this form up here, but I'm going to use my shortcut. All I do, I'm doing 3 times 2, power to a power. So this is just x to the 6. Okay, next one. 3 squared to the 4th power. I just do 2 times 4. That's 8, so it's 3 to the 8th. And then I could also do z to the 5th to the 9th power. Just multiply the exponents. Z to the 45th power. So those are some basic ones. And yes, it doesn't always have to be positive. I can have negative exponents here. What if I had a -2 instead of a +2, or a -3 instead of a +3? I apply the same rules, and you're going to see that in a bit. A couple more. Let's do 2a to the 3rd power. So this is where I see a lot of errors when I give examples to my students. So when you do a power to a power, you don't just do the letter, you do each piece. So remember, if there's no number with the exponent, it's really an invisible one. So if you want, you can put a 1 to each of your bases. So it's 2 to the 1st times a to the 1st. And we're going to use this one. I take each base separate and raise it to the outside exponent. And I multiply them. So really, this just becomes 2 to the 1st times 3. So I multiply the exponent. So it's 1 times 3. So this becomes 2 to the 3rd. And then 1 times 3 for the a piece is also 3. So it becomes 2 cubed, a cubed. I can't simplify the a cubed anymore, but I could do 2 to the 3rd. I could leave it like that, or sometimes it wants me to expand it out all the way, which is just 8 a cubed. So both of these are acceptable. If it wants you to write it out without the exponent for your number as your base, just expand it out. If not, just leave it in exponential form. Both are correct, just whatever form it wants you in. Let's look at this one. Let's do 6x cubed y to the 4th, z to the 2nd, and let's raise it to the 4th power. Okay, so each of my pieces has an exponent except for the 6. So if you want, you can put a 1 there to help you. And then I just take each of the bases. There's 4 bases in this case, 6, x, y, and z. And then I just raise each piece to the 4th power. And that means just multiplying your exponents together, keeping the base. So the 6, 1 times 4 is 4. 3 times 4 for the x piece is 12, so it's x to the 12. For the y piece, it's 4 times 4, which is 16. And for the z piece, 2 times 4 is 8. And that would be my answer. If it wants you to expand out to 6, I could do 6 to the 4th power. 6 times 6 times 6 times 6, which on the calculator would just be 1296. You can do that. So if you wanted, you could also say 1296, x 12, y 16, z to the 8th. Both are acceptable. So it doesn't just have to be 2, it could be more than 2 terms inside. It could be 4, it could be 10. Okay, let's look at now 2 with division. So it doesn't just have to be multiplication, it could be division like so here. So let's say I had x squared over y to the 7th, and I want to raise it to the 4th power. So my rule states I take each piece and multiply the exponents. Keep the base. So for my x piece, 2 times 4 is 8. It stays in the numerator. And then for my denominator, it's still y. And then 7 times 4 is 28. And that's my answer. Another one. Let's do 2 cubed x squared over 3 to the 4th, y to the 5th, and let's just do this cubed. So each piece, I followed my division rule for powers. Okay, I'm going to start with the 2. Every piece has an exponent with the base, so if it didn't, I could put a 1 there to help you. So I start with the 2. Since it's power to a power parentheses, I just multiply the exponent. So it's 3 times 3, that's 9. The x piece, 2 times 3 is 6. Now I go to the bottom part of the fraction. For the 3, 4 times 3 is 12. And for the y piece, 5 times 3 is 15. And that's my answer. You could expand out 2 to the 9th and 3 to the 12th, but those are going to be really big numbers, so we're just going to leave it as that. And we're done with that example. Now we get to the slightly more tricky part with negatives. So it's the same with negatives. So for example, let's say I had this. Let's say I had 2 over 3 to the negative 2. And I wanted to do this. So let's just see what that is on the calculator first without doing it. So let's put it in 2/3, close the parentheses, and then I raise it to the negative 2. I'm going to get 2.25, and as a fraction, that's 2 1/4, and an improper fraction, 9 over 4. So we should get 9 over 4 as our answer at the end. So let's see how to do this without a calculator. So first thing, if there's no exponent, you can put the exponent. It's really an invisible 1. So it's really 2 to the first over 3 to the first to the negative 2. So remember, power to a power. I keep the base and just multiply the inside exponent to the outside exponent. So 1 times negative 2 is negative 2. So you have to know your rules for negatives. 2 negatives equal a positive. A negative and a positive equal negative. For the bottom, 1 times negative 2 is negative 2. So that's our first part. Now I use my negative exponent property. And remember, if it's positive in the, if it's negative in the top, the numerator, it's positive in the bottom, the denominator, and vice versa. So in this case, I have a negative exponent on the top, so to make it positive, I'm going to move it to the bottom. So to make this positive, I rewrite it as 2 squared. And for the 3 to the negative 2, since it's negative in the bottom, I move it to the top and rewrite it as 3 squared. Now this can just simplify. 3 squared is really just 9, and 2 squared is just 4. So I get 9 over 4, and we're done. So that's how you go about it without a calculator. Use my power rule, move the exponents, make them all positive, and then just expand out and get an answer. I can also do it with non-numbers. For example, let's do x squared over y to the negative 7. I'm going to do it to the negative 3rd power. So remember, power to a power. I keep the base, multiply the exponents. 2 times negative 3 for the x is going to be negative 6. And then for the y piece, negative 7 times negative 3 is positive 21. Now I need to rewrite this with just positives. So since it's negative with the x piece, to make it positive, I put it in the denominator. The y is already positive, so I'm not going to do anything. I'm going to leave it. And now the top's just 1. If there's nothing there, just put an invisible 1. So my answer is 1 over x to the 6th, y to the 21st, and I'm done. So your goal is, remember, at the end, I don't want any negative exponents in my answer unless it says so. So if it doesn't say so, write it without negatives. Move it to the opposite part. If it's already positive, you're good. Don't change the positive exponents. Only change if it's a negative. If it's no negatives in your answer, leave it. You're done. Okay, let's look at another one. Let's do negative 2 to the 3rd. No, let's just do negative 2. My bad. Negative 2 x squared y to the negative 4 all to the negative 4. So remember, first thing, if there's no exponent, I'm going to put it there. So the first thing I'm going to do is start with my negative 2. So negative 2, and then I do 1 times negative 4. That gives me negative 4. X squared. 2 times negative 4 is negative 8. And then for the y, negative 4 times negative 4 is positive 16. Now I need to simplify. So wherever there's a negative, I move it to the opposite part of the fraction, and then keep the base. Just change the sign of your exponent. So for the negative 2, I'm going to move it to the bottom part of the fraction. make it positive. Same with the x, since it's negative on the top, I move it to the bottom to make it positive. And the y piece, I just leave alone. And then I have to do negative 2 to the 4th power. And be careful when you have a negative to a power. It's negative 2 to the 4th power, not 2 to the 4th power with the negative. So be careful, and I'm going to put this right here. Negative 2 to the 4th power is not the same as negative 2 to the 4th power. Because when I use order of operations, this is saying negative 2 times negative 2 times negative 2 times negative 2, which is really just 16. This is saying I'm doing 2 to the 4th, and then I'm adding a negative at the end. This is just negative 2 times 2 times 2 times 2, which is negative 16. 16 is not equal to negative 16. So be careful. So sometimes it's helpful to put parentheses around each piece so you know, because negative 2 to the 4th power is not the same as negative 2 to the 4th. I'm doing negative 2 to the negative 4th, not 2 to the 4th add a negative. So really I can now simplify this. I know negative 2 to the 4th power is 16, x to the 8th, y to the 16th. And if you don't want to do it by hand, you can also use a calculator. But you got to be careful. Okay, so what I do is this. I put the parentheses, I type in negative 2, close the parentheses, and now I hit the y to the x, negative 4. And then second fraction is 1 over 16. If I don't do it and I just do this, y to the x 4, it does y to the x 4. So just be careful with the exponents sometimes. Some of the calculators, it won't mess it up the order of operations, but sometimes if you have the scroll bar calculator, it will mess it up if you don't put the parentheses. If you have the other calculator that has the scroll button. This calculator won't mess up the order of operations with the negative 2, but some will mess it up. And let's just look at one last example with the negatives. So when it says evaluate just means get an answer. So let's say I wanted to get an answer for the following. Let's say I wanted to do 3 to the 4th times 2 squared times 6 over 3 to the 5th times 2 cubed times 6 to the, let's do 6 squared. And let's say I wanted to raise it to the negative 3rd power. So it doesn't matter how many terms there are. We just want to simplify this. And you can put it on your calculator and try, but sometimes it might give you a weird decimal and might not convert to a fraction. So we're just going to follow our properties. The first thing is, remember, when it's something in parentheses raised to a power, I'm going to clear the parentheses. Take each piece, raise it to the outside power. So for the top, 4 times negative 3 is negative 12. For the 2 times negative 3 is negative 6. And for the 6th piece, if you want, you can put an invisible 1. 1 times negative 3 is negative 3. So I'm done with the top. For the bottom, I start with the 3. 5 times negative 3 is negative 15. For the 2, 3 times negative 3 is negative 9. And for the 6, 2 times negative 3 is negative 6. So now I have it with just no more parentheses, power to a power. So now it's just regular exponents. However, I don't like the negatives, so I'm going to rewrite it with strictly positives. So, negative in one part means positive in the other. So for the 3 to the negative 12, that becomes positive in the denominator. For the 2, the negative 6, positive in the denominator. Same with the 6. Here, each of these pieces will go on the top now since they were all negative in the denominator. Now I need to simplify this. Now I can use my quotient rule. Bases that match, I just subtract the exponents. So in this case, 3's match, 15 minus 12, that gives me 3 to the 3rd. Or just think, how many more 3's are there in which part of the fraction? That will tell you which part of the fraction is more. So in this case, there's 3 more 3's on the top than the bottom. If it was flipped around, then I'd put the 3 to the 3rd on the bottom. In this case, 2 to the 9, 2 to the 6, 9 minus 6 is 3. And then 6 to the 6 over 6 to the 3rd is also 6 to the 3rd. 6 minus 3. And the bottom is 1. Now I can simplify this. This just becomes 9 times 2 cubed is 8. 6 to the 3rd power is 216. And I just do that on my calculator. 9 times 8 times 216 gives me 1552. 15,552. And I'm done with my answer. So when you have more than one term being multiplied to a power, just follow the rules. Get rid of the outside parentheses exponent, power to a power. Rewrite everything with a positive exponent. Simplify if necessary. And then expand out your answer since it wants you to evaluate, get an actual number. You can try putting in each piece and doing it, but again, just follow your exponent rules. So, let's see. One more. I know I said that was the last one. We'll just do one more example. Let's do 3 to the negative 4 over 2 to the negative 2 raised to the negative 3. I want to evaluate it. So to evaluate it, power to a power, first thing, 3. I multiply the exponents. Negative 4 times negative 3 is 12. And then for the 2, multiply, that gives me 6. And now I just expand it out. 3 to the 12th. Let's see if I can do that on my calculator. Yeah, that's 531,441. And then 2 to the 6th power is 64. And that would be my answer. And that's all you leave. Don't simplify. You can't really simplify it. You're done. So this concludes the video on properties of exponents part 2. In this video, you learn the number raised to the 0 power and a number inside the parentheses raised to another parenthesis, or sorry, an exponent raised to another exponent, power to a power. So again, you now have 5 properties: the product rule, the quotient rule, your negative exponent rule, your 0 exponent rule, and your power rule. Please apply these 5 properties whenever you have any exponent type question. Again, your goal is to not have negative exponents in your answer and to simplify as much as possible. This is Mr. Holmes signing out, and enjoy the rest of your day. Take care. Bye-bye.